Okay, this is a software called Simulink, and what I've done in this software, Simulink is a part of the MATLAB software. So, as a part of in Simulink, what I've done is I've built a position control system. So, this is the position control system here. Here's a motor which takes a voltage input and gives a position output. The position output is then compared with the desired position. An error signal is generated, it is amplified, and that amplified voltage is given to the motor. Okay, uh, and the output position is going to be plotted in this graph. The gain here and that the error is multiplied with can be controlled by this slider. And what I've done as a desired position is I've given a step input. So basically at time t0 the desired position becomes a constant value. So now before that the desired position was 0, so you can assume that the output position was also at 0. So we are suddenly changing the desired position from 0 to a particular constant value, and we want to look at what happens to the output. So let me run this simulation. So when you run this simulation, you can see that you get a response like this. So the position starts at 0, it increases, and there is a bit of an oscillation, and then it settles down at 1, which is the desired value. So it takes a bit of a time for the position to reach that value. So can you see that what we have done is um, the this control system is able to get to the desired position value. Now let me change the gain of this and make this gain negative. Okay, so right now this was a negative feedback loop. The position came to a constant value, but now I'm going to change the gain to negative. What do you think would happen? So let me run this, and you can see that things have not gone that well. The motor position started off with 0, and it's just going negative, and it never goes to 1, which was our desired position value. Basically, by changing the sign of the game, what we have done is we have made this control system from negative feedback into a positive feedback loop. So if there is an error, that error is just going to keep on getting amplified, right? So let's say there is an error. Let's say this angle is greater than the output angle. We generate an error, and instead of moving so that the error reduces, the motor moves so that the error increases. And if the error and when you come back again, the error increases more and more and more, and so the system essentially becomes unstable.